you, Professor Takaya. Now I start the president. Good noon, respected colleagues and experts. Today I'm honored to present our research on odor impact patterns and health risks of various temperatures in the rubber product manufacturing industry. This study was conducted by Professor Li's team of odor pollution control, Ministry of Ecology and Environmental of the People's Republic of China. Sorry. Let's study the background. The complaint rate for the odor pollution from the rubber product manufacturing industry, we called it RPM industry, ranked fourth among all industries in China from 2021 to 2018 to 2021. And the RPM industry included 7 subcategories, including tire manufacturing.
Sorry. I can. Okay. Now the slide has changed. Okay, now.
Yeah. Okay. The RPM industry were divided into 7 subcategories, including tire manufacturing, rubber part manufacturing, recycled rubber manufacturing, and so on. And which subcategories of industry exhausted gases will cause odor problems and health impact for the surrounding residential areas. In terms of material analysis and health impacts, many studies have focused on gas emissions from raw rubber production and rubber product applications. However, the manufacturing processes are typical processes that release chemical compounds have not received sufficient attention. In terms of odor impact assessment, it is crucial for understanding the separation distances of odor pollution through dispersion modeling. In China, with high population density, industrial facilities are close to the surrounding areas, and residential buildings can be as high as 80 meters. This means that residents at different heights may face varying levels of odor pollution and health risks. However, the height of the receptor has seldom been considered. Therefore, odor impact patterns and health risks of various enterprises were analyzed in the rubber product manufacturing industry of this study. Part 2, Materials and Methods. We investigated 20 RPM enterprises located in eastern and northern China. And we conducted, and from 2019 to 2024, we conducted a sampling campaign and collected 128 gas samples from the exhaust stack outlets of different enterprises.
Sorry, Yang-chan.
Yeah.
Could you change the slide page? Okay. Now, which page are you explaining now? Which page?
Which place?
Now I can see page 9 on the screen. Is it right?
Yeah. Maybe my Wi-Fi is too low. Too slow. Yeah.
Are you explaining about page 9 now?
But I can't have another one.
On the YouTube channel, I can see slide page 9. Is it okay?
What if I? Can you see my screen?
Yes, I can see page 9. Section number 2.2.
Yeah, 2.2. Yeah.
Is it okay?
Yeah.
Okay.
Okay.
Please continue the presentation.
Okay. In terms of for chemical analysis, we used GC-MAS systems to identify 146 VOCs. And for odor concentration, we used a triangular odor bag method by the Chinese regulation. We used the Kappa model for dispersion modeling of odor and VOCs, and these are the input data. For odor impact assessment, the odor impact criteria, OIC, can serve as a regulatory benchmark to determine separation distances. Owing to the lack of standards for odor impact assessment in China, the German OIC were used to assess odor separation distances by an odor frequency above 19th percentile. For health risk assessment, the HQ for non-carcinogenic effects and CR for carcinogenic effects were determined. These are the calculated formulas. Part 3, results and discussion. In picture 1, the columns represent the individual VOC concentration, and the black dots represent overall VOC concentration. And in general, we found that the tire manufacturing subcategories had the highest overall VOC concentration. And across the 6 subcategories, alkanes and terpenes were the most prevalent compounds. The concentration of the hexane and other alkanes were particularly high because these compounds were commonly used as softeners in these processes. And we found that many VOC emissions come from raw and auxiliary materials, so more green materials are required to reduce the environmental pollution. In picture 2, the columns represent the odor concentration, and the blue dots represent the odor emission rate. We found that Recycled rubber manufacturing represented the highest odor concentration, with an average of 13,000 OU, while tire manufacturing ranked second, with an average about 1,800 OU. But the emission rates of recycled rubber manufacturing and tire manufacturing were comparable, with the same order of magnitude. That is because tire manufacturing enterprises generally have high production capacities and large exhaust volumes. In the figure 3, these are the results of odor impact assessment. The ordinate represents the odor frequency, which was simulated by Kapap model. Abscission represents the vertical height of the residence. In general, for these 9 enterprises, the odor frequency increased from the ground of the height of the residence and then decreased as the height further increased. The highest odor frequency was generally observed at 40 meters to 60 meters, corresponding the 30th to 20th floors. In this figure, the separation distances were outlined. Among the 6 tire manufacturing enterprises, 4 tire manufacturing could cause odor nuisance to the surrounding residents on the ground layer, with varying maximum separation distances for the ground layer of 0.3 kilometers to 3.5 kilometers based on the wind direction. At last, we assess the health risks. In this figure, the HQ were calculated for non-carcinogenic risk. Because tire manufacturing is the subcategory with the highest VOC emissions in the RPM industry, so we take tire manufacturing for example. The cumulative HQ values were lower than 0.0025, which is much lower than the non-carcinogenic risk threshold of 1. Indicating that there was no significant non-carcinogenic risk to the surrounding areas. The largest contributor to the cumulative HQ was acetaldehyde. In this figure, the CR values were calculated for the carcinogenic risk. Similarly, the cumulative CR values for all tire manufacturing enterprises was lower than the carcinogenic risk threshold. However, the CR value was close to the threshold, indicating a potential factor to monitor. The largest contribution to the cumulative CR was also acetaldehyde, followed by benzene. The part 4 conclusions. In summary, we obtained the following key findings. 1. All tire and recycled rubber manufacturing enterprises caused odor impacts. 2. Odor impacts in RPM industry peaked vertical at the height of the 14 to 16 meters due to vertical dispersion. 3. The maximum separation distances of odor impacts along the prevailing wind directions ranging from 0.3 to 3.5 kilometers. 4. None of the enterprises posed carcinogenic or non-carcinogenic risks to surroundings. Acetaldehyde and benzene require special attention and monitoring for the tire manufacturing industry. This study provides important evidence for the management and control of VOCs in the RPM use. Thank you very much. Welcome to Exchange.
Thank you very much, Zhang. So now the session is open for discussion. Any questions from the audience?
May I ask a question?
Oh,
Yeah.
Jane, okay.
Yeah. So, thank you for your presentation. I think in your conclusions, you had one comment that the rubber product manufacturing has no health bad adverse effects on people's health. So can we say that generally speaking, we just need to care about the other issues for this industry, but no need to worry about their high adverse health effect?
Yes, thank you very much, Professor Xi. And through this study, we found the health risks there's no health risks for residential areas from the rubber product manufacturing. But in the workplace, we think there have the health risks for workers.
So you mean the indoor air in the factory?
Yeah.
Okay.
Yeah.
Okay.
Oh, yeah.
Thank you.
Okay. Thank you. Thank you very much.